everyone. My name is Sara Raos and I'm a power system engineer from the Faculty of Electrical Engineering and Computing, University of Zagreb. And today I will show you the evaluation model of enhanced geothermal system projects based on multi-criteria decision making. So this is the short outline of today's presentation. So the largest share of newly installed capacities around the world are covered in wind and solar, leaving the geothermal energy as one option that is still not considered enough. However, geothermal energy has a lot of advantages. It can provide vast and continuous year-long baseload energy, and it is also dispatchable on demand, unlike wind and solar. It can also, it's also applicable for different end usages such as heating and cooling purposes, but also electricity generation and both combined heat and power generation. Additionally, the geothermal power plants have small land use intensity, and they are very scalable in installed capacity, ranging from a couple of kilowatts to a couple of hundred megawatts. Additionally, geothermal energy is also described with near to zero greenhouse gas emissions. However, of course, there are also disadvantages of geothermal energy and geothermal projects, and the main drawbacks are actually related to the risks and uncertainties of sustainable fluid provision from the subsurface reservoir to the surface, and also very large upfront costs, which are mainly related with exploration, drilling, and stimulation of the reservoir itself. However, the traditional geothermal systems that are based on the well-known technology, they can exploit only geothermal energy from the high enthalpy, high permeable rocks, but huge potential is actually present in low permeable rock that is exploitable only by new technology, new techniques, and those are called enhanced geothermal system. But these new technologies are still not yet commercially competitive. So in natural occurring geothermal systems, which are also called hydrothermal systems, at some medium depth we have low to medium resource temperatures. We also have an existing fluid that can carry the heat from these rocks to the surface through the fracture networks, which is also, so those are the small pathways through which the fluid can be conducted to the surface. However, what happens if at some medium depth we found a resource which has low temperature and there is insufficient or no fluid that can carry this heat from the subsurface to the surface, and additionally there are limited pathways, meaning that the fracture system does not exist. Where in this picture comes the EGS technology. Basically, we are using different stimulation techniques to stimulate the reservoir. Basically, we are creating a subsurface fracture, which is an artificial, let's call it man-made reservoir. And then we are injecting the surface water to one or more injection wells, and then circulating into the reservoir and collecting the heat from the rocks. But the EGS technology can provide exploitation of this huge geothermal potential on a wider geographical scale and wide temperature at wide temperature ranges. Additionally, the EGS projects are very, very highly site-specific, and the sustainability assessment of such projects actually needs to take into account three different aspects, and those are technology sustainability, environmental and social impact, and then, of course, economic sustainability. And therefore, we need to consider a multidisciplinary approach, meaning that we need to take into account all the subsurface phenomena, and which is related mainly to rock properties or geothermal fluid properties, and then all the surface phenomena related to the technology, so the power plant type, the extraction technology, the geothermal system, which is highly influenced by the potential end users and their characteristics, which is of course in closer relationship with the environment. All these four aspects highly influence the economics of such projects, and therefore it's a very complex problem. Additionally, the methodology that we have developed when modeling this model is that we can evaluate, we can assess two project groups of interest. the greenfield projects or the brownfield projects. Of course, we need to take into account that based on the type of the project that we are assessing, the reliability of the results of our evaluation will decrease or increase. Of course, if we have a brownfield project, meaning that we have a year-long operational data or evaluations based on these year-long operations, then of course the certainty level of these input parameters is higher and the credibility of the results is better. So all this was the motivation to develop this evaluation model. It is at this stage a simulation model developed in MATLAB. The MATLAB tool also allowed us to model, to create a user-friendly graphical interface and a standalone application which can be downloaded and run on every computers, and this is what most of the existing tools actually lack today. The methodology also uses a vast number of input parameters that can be both inserted by the decision maker, so or the tool can use the data from the internal databases. Additionally, the model is a modular model, meaning that each module can be used separately to pre-calculate, simulate, or prepare data for the main core of the model. And this main core of the model is actually the calculation of energy production, and followed by the economic calculations based on the discounted cash flows. Additionally, what is also new in this approach is that we have a built-in multi-criteria decision-making model, which can then process the raw data into a decision and give decision maker, a user, decision which scenario is the best one for the inputted parameters. So basically, we have 5 main groups of input data. Those are subsurface parameters, mainly related to the rock properties and geothermal fluid properties. Then we have surface technical parameters, financial parameters related to the parameters that we need for the financial analysis, economic parameters that are mainly costs, then different types of incentives and subsidies, and lastly, there are environmental parameters. Once all the data has been inputted in the model, we can size the project. Mainly, we are calculating the installed capacity of the power plant, and then we can calculate the produced energy throughout the lifetime of the project. We have also this model can evaluate the EGS resources between in the temperature range between 60 and 175 degrees Celsius, and we have also modeled for production modes. Let's call it. So only heating mode, production mode, and only electricity production mode, which is based on the organic Rankine cycle power plants, and then we have 2 combined heat and power production modes, both in series and parallel configuration. After that, we determine all the costs during all the phases of the geothermal projects throughout the whole lifetime. We can either use default cost correlations, or the user can input pre-calculated user-defined data. And then in the end, we obtain the results. So we obtain performance metrics such as I mentioned, produced energy, losses, efficiencies, and etc. And of course, after that, the economic analysis gives us the economic metrics such as net present value of the project, levelized cost of electricity, cash flows throughout the project's lifetime, and everything is shown in graphs or numbers. And then in the end, there is this separate multi-criteria decision-making model, which is basically based on the usage of analytical hierarchy process, which enables us to give the relative importance to the defined influencing factors in the geothermal project, and then to rank the runs scenarios. Well, we have seen that the development of an EGS project is very complex and multidisciplinary problem, and that all was actually the motivation to develop an evaluation model to actually facilitate this decision-making process. The model takes into account the 5 main different aspects. So this is geological setting, technology, economics, environment, and society. And we have also seen that the criteria selection, weighting and ranking methods, if they are used appropriately, they can be actually a powerful tool for decision-making of sustainable energy projects. And the new thing in development of this evaluation model is that this approach actually enables 2 things, and those are the comparison of different options of geothermal utilization at one site, and then comparison also of different geothermal production sites. And for any further results or how to use the tool, you can contact me on my email, and this is actually the interface of the tool itself and the standalone application. Thank you very much.
Questions?
Just to confirm, is it available for sharing the tool?
It's actually, yeah, it was, so let's call it the first stable version was available as part of the MED project. And I can send you the link of the project. The project actually ended starting this year. And the next versions should be online and available in, I don't know, maybe a year, because we will also include the optimization. So for now, it's just a simulation model.
Maybe one question related to the risk of geothermal energy and getting it as a source. So, is it possible to have a financial risk estimate for that?
Well, it's a complex problem, yes. And we were, so one, let's say, group in the project was actually dealing with this. It's not really my expertise, so I will probably take their conclusions and include it in the next version of the tool. At least I will try.
Thank you.
Because I mean, if you look at the whole project like this, it's very complex because you have a lot of uncertainties and risks in the subsurface, and then there is a lot of complexity on the surface, the power plants, and then the environmental impact and social impact, because also the EGS's projects are related to the potential seismicity, which is then related to the society, because you can have a feasible project, you can have like I don't know how many megawatts of power plant, and then you have I don't know 3.5 magnitude of Richter of an earthquake, because you're injecting the water into the subsurface, and then the society says we don't want to have that into our backyard.